computer. All right, so from the sheet, you realize this is our learning intention is learning to define, evaluate, and compare functions. And in order for us to be successful, we're going to focus on one thing today and for the rest of this week. It's using tables, graphs, equations, or other written descriptions to determine if a function is a linear or nonlinear function, and then also give examples of each. We'll go through a Nearpod activity and a Desmos activity. But before we get started, I want to review something we went through. Do we remember what type of examples or what type of methods can we use to determine if a relation is a function? Do you remember the different types of ways we could look at that to see if it's the equation or what we're looking at is an actual function? We could use the vertical line test. All right, so if we have a graph and then we have a function in there, we could use the vertical line test. That vertical line test will tell us if it's a function or if it's not a function. Okay, in this case, this right here is a function. Another example we could look at is by looking at the x values within a table or a set of points or a mapping. All right, so we have the domain, right, and the range. 1, 2, 3, 4, 3, 2, 1, 6. With a question, with a table like this, we realize that 2 is repeated, not 2, 3 is repeated twice on the domain side, which would make this not a function. Okay, just to review. Now, if we're looking at the new topic where it talks about linear versus nonlinear, nonlinear versus linear functions. If we're looking at this, we already know what makes a function, right? So when we're looking at linear versus nonlinear, we already know what makes a function. Now we're looking at what makes it nonlinear from linear. Does anyone have any idea what makes something? But when we talk about linear equations and nonlinear, not equations. We're talking about linear functions and nonlinear functions. We're talking about, actually, let me put this. So, you know how we talked about functions? And then you have some stuff that are not functions. And that's by using the vertical line tests and so forth. Now we have underneath the functions, we're going to have the linear ones, and then we're also going to have the nonlinear ones. Cool. So we're going to focus on what makes it linear from nonlinear. Let's get on this new slide. So to figure out if something is linear, we basically say it's a straight line. So a linear function, thank you. A linear function, so I have my graph, looks something like this. That's a linear function. Or that's a linear function. That's supposed to be a straight line. Basically, all the straight lines are linear functions. All right, all the straight lines are linear functions. And if we test this, we realize that it is a function if we do the vertical line test through it. If we do the vertical line test through this line, it will tell us that it is a function, right? Because the vertical line test will only go through it once. All right, all these straight lines are functions. A vertical line is not one because a vertical line is not a function, all right? That's one of the only straight lines that would not be considered a linear function because it's not a function. So what do we think a non-linear function looks like? Keep in mind, it has to be a function, but it can't be linear. So someone said a wavy line. Because if we do the vertical line test through this, that's a function, but it's not linear because it's wavy. One more example. That right there, it's a function because it passes the vertical line test, but it's not linear. So it's considered to be a non-linear function. All right, so that's just a brief overview of what linear versus nonlinear functions are. Just to recap, linear functions are straight line that passes the vertical line test, and nonlinear functions are not straight lines that also passes the vertical line test, period. All right.